Greetings. Welcome back to my channel. This is a quick presentation slash commentary on a idea that's come up in some of the kind of popular posts around coding, which is whether junior developers actually really understand programming. And in the spirit of the Betteridge's law, and to spark some engagement for the algorithm, or just create some pure clickbait, to be perfectly honest, let's just go ahead and say no. They don't. In more seriousness, though, the question actually is worth looking into in a little bit more deeper way and stuff like that. And still, the thing about it is that there actually might be, the question actually might be, most cases, probably not. And a lot of cases that they don't. And that seems very narrow-minded. And I know a lot of you are probably commenting right now and stuff like that. And that does seem pretty provocative. So before we move on, I will let you say that this is going to not be a flame fest. I promise to try to make this as nuanced as possible. And so we're going to take a bit of a break here. I will now present a picture of a sea otter for you to help relax and stuff like that. Release a little bit of the tension when it comes to the clickbait. And given that, a little humorous break there, let's move on to the real commentary. Now, why do I think that it's fair to say that a lot of junior programmers may not actually understand programming? And the reason is fairly simple. There is a lot more demand for code, which means a lot more people are doing it. And as that demand has grown, the demands on education and training have shifted greatly. And so there are a lot of demands for people to have smaller sets of skills that can still participate in industry than ever before. And probably nowhere is that more evident than the notion of a coding boot camp, in which you can take someone that is fairly motivated, or maybe even just wants to do coding and because they found it's a good job, and within a matter of months or a year at most, turn them into somebody that could start participating in the workforce. And certainly during the pandemic and era before that, in the 2015s, 2016s, there's such a big hiring boom that a lot of these code schools were fairly successful in that regard, because they were in fact feeling demand for anybody that could come up with anything that vaguely resembled something that was a workable JavaScript program, despite, their backgrounds or anything like that. And I would certainly like to say that that's uniformly a good thing. I don't necessarily want to be a gatekeeper when it comes to our industry. However, there are limitations to that model. And what those limitations do is really hurt the students that don't have a deeper understanding of the field, because they become very vulnerable to the cycles that we are seeing now in terms of hiring, but then firing as money is no longer cheap, or as companies no longer want to do things like just hire as a competitive asset. We have more people, and that just prevents them from working at other companies. We don't necessarily need them to do anything as long as they don't work for our competitors, because they are so flush with cash, for example. And what that does is just create a lot of people that are very burnt out on the industry. The reason that there's so much anxiety around AI coding is that there is a certain group of less experienced programmers that see what AI can do, and it looks exactly like what they can do, but just faster and better. It's got to be a very frightening concept to be like, well, my job can be completely taken over by this AI written by people that are, to be perfectly honest, extremely motivated to do exactly that, which is replace you, this junior developer, with an AI subscription that the more senior people can use, so they don't have to bother, quote unquote, with those pesky junior developers and their questions. Now, this, of course, is extremely short-sighted as a whole for an industry, because everybody was a junior developer at one point, especially those senior developers that are insistent that the current batch of junior developers are really more of a waste of time, and I'd much rather pay for an AI subscription. Those people were also juniors, and in some ways very much still are juniors. They may see themselves as experts, but they are much more really vocal and overly enthusiastic beginners, I would say. So, but that pressure on to just get someone who can do the basics, very, very minimal amount needed to do coding, has also pushed itself into a 4-year degree. Now, if you get a 4-year degree in computer science, there are certain things that you will still have to cover that is more in depth than some of those code schools, and you have to do a little bit more in depth. But I'm here to tell you that from my perspective, the academic curriculum for computer science has become a lot less rigorous. And the reason it has been is because of demand. There's much more people coming into the field. You have to make it more accessible. 2, there is stuff that you have to learn that we didn't have to learn when I was in school. There's certain technologies and ideas that didn't even exist. And those skills are very much in demand. It would be ridiculous to offer a 4-year programming degree at this point in which you couldn't at least learn about web programming or front-end programming, right? Much less it being a requirement for you to get a degree. But when I, of course, was studying programming, the web didn't even exist. Therefore, of course, we couldn't study it. That goes on to lots of other things. You know, what is necessary now is that there's much more need to have a pragmatic understanding of how to use things versus a more theoretical understanding. For example, when I took my database courses, we spent a lot of time studying the fundamental ideas behind relational algebras, normal forms, and the theory that goes into creating a database, and then working a little bit with SQL. And then that time we also did a lot of stuff with object-oriented databases, which at the time people thought were going to be the next big thing. Of course, they weren't. SQL databases are, of course, very alive and well, and those object-oriented databases have evolved to things like document stores or all sorts of these other types of NoSQL, as they used to call them, database solutions. But there was not nearly as much programming as there was nowadays, where someone who takes a database course, I would expect, and it would be very reasonable, that the vast majority of the time that they spend is on writing SQL and then maybe doing some additional work with document stores or using other non-traditional databases. And that if they spent any time on database normalization, it would be just in a very brief overview. And I'd be stunned if the ideas behind the relational algebra came up at all. So same with networking. Networking programming is all about programming now, practical uses of networks. When I was studying it, we were learning more about network fabrics and how the underlying hardware and those stacks worked, because the amount of network programming that you did was much smaller, and it used a much smaller set of ideas. When we did our network stuff, when we eventually got into coding, we all used the basic socket API, the lowest level type of stuff. Protocols like HTTP didn't exist. We would study things, maybe talk a little bit about coming up with your own little protocol, stuff like that, or maybe log into an basically a mail server that didn't require authentication. They had those back in the day, where you could literally go in and just start typing away the email protocol. And I'm here to tell you that there was quite some interesting abuses of that infrastructure back in the day. But now a networking class would all be about network programming, about HTTP, about how to do WebSockets and so on and so forth. When I was doing programming, we would have to learn a lot more about programming languages and stuff like that. And that's where I think this is where the first thing that has dropped off in the modern curriculum has been, is that the theory behind computation and programming languages is much more often just an elective, or even something that is only encouraged for people that are really interested in it as a senior, or is now often relegated to being a graduate level course that you might even need to get permission to take if you're only an undergraduate. And the reason being is that something has to give. And unfortunately, that was one of the things that did, was since there was a demand for just a pragmatic understanding of these types of things, and a demand for people that only understood maybe one programming language, maybe had a little experience with one or two, but mainly focused on one, that was fine. And certainly it was very hard to justify things like theoretical computer science in terms of studying grammar models, finite automaton, Turing machines, and doing things like proving certain things about certain stuff. That is very hard to justify given all the additional demands on what a programmer needs to do. And that's when computer science as a degree did much more into a computer programming or even software engineering or coding degree. And that's fine. That's actually to be expected. Again, those market demands make sense. Secondly, as I've talked about in the past, the bar to entry to getting into a program or being able to program is way lower than when I started. My days to get into the program, they had GPA requirements and all this stuff. And the reason being is that we had to have access to very expensive networking and workstations. We had to be in a computer lab with $50,000 workstations that were connected to internet things that cost a fortune to maintain. You know, it is really weird to think about how much better things have come. But basically, I remember when we were excited that we got a whole 10 megabit Ethernet over coax. This was before Cat5 cables going in a lot of places. And we were starting to make those links happen on a wide scale between big universities. Now I have a 2 gig fiber connection for $40 running on a $500 laptop that has the power to do any type of programming I would want to do, maybe outside some large language models or some really intensive scientific computing. But it certainly is not something where you need a $50,000 machine just to write some C code. And so because that bar is lower, you cannot justify that level of academic rigor before you even let in somebody into a program. And that's fine. And any of the professors that are thinking, oh, well, I'm longing for the old days. Well, you know, fields evolve and fields change, and you should try to adapt to the demands that your students are being faced with. That being said, I'd have to say that one of the things that they are missing from this is that right now there is so much change in programming languages themselves that people that don't understand the fundamentals of programming languages are actually at a real disadvantage now, maybe more so than ever before. There's interest in new programming languages in all sorts of areas in which they never would have thought to have happened before. If you take a look at the use of C and C++ in systems programming around operating systems and embedded systems, no one would ever have thought that that would be the only two languages that you do things in, much less have an environment where the government itself says that everybody should move towards memory-safe languages like Rust and step away from C and C++ in order to get better memory safety and security for underlying infrastructure. That was unheard of and unthinkable even 5 or 6 years ago. Now it's just a reality. If you take a look at web programming, what JavaScript is changes constantly. There are new features added to JavaScript and TypeScript every year, and using them effectively requires you really learning a very different dialect of the language than what people thought it was previously. Take languages like Java that are now adopting new language features at an incredible rate. C# is an excellent example of a language that has evolved to meet a lot of demands of what people are asking from it and how it's used. And adding a lot of features that, again, if you just started out learning the basics of one language, if you wanted to get into that environment, that'd be very difficult. Python 3 is adding things. Languages, and there's new languages that people want to learn and use, like Elixir, and so on and so forth. So there are a lot of programmers that are stuck because they never had the fundamentals around programming languages that were required in my day. That got tossed to the wayside because of this expediency to do other types of things, using frameworks and gluing things together, and are now faced with the biggest shift in language usage and language features that I've ever seen since maybe the onset of object-oriented programming in Java in the 90s. And that makes for a very interesting dichotomy for where those people that do have the skills that can move from language to language have a much better career path for those who really feel stuck and can't learn to code outside a certain environment. And there is very narrow specialization, very narrow. There are people that really aren't comfortable out of not just programming in TypeScript. That's the only language they feel very comfortable with. But the vast majority of what they do in TypeScript is in a certain framework in React, and have a hard time moving to either other frameworks because they've done so much work in that environment, and B, have such a superficial understanding of what programming languages and frameworks are and how they work that they can't move to something else. They've gotten too dependent on the existing documentation, what people do for them in this one thing, and do not have the skills to move to something bigger or different. And certainly, there's some people in the industry that like to lord that over them versus help. The constant joke is about how back-end engineers look down on people that do a lot of React and TypeScript, for example, not realizing, hey, how miserably difficult that can be and how hard and challenging that stuff is. And two, there's no reason that these people can't be useful in other types of programming and applications if they're given a little bit of help. But a lot of them also, to be fair, are basically stuck on this endless cycle of this is the only thing that anybody needs to do stuff in, that you could possibly never need to ever program something that wasn't TypeScript or React. Why would you ever want to use another language? Because that's all they really understand or know or want to work on. They will go out and also kind of attack people that do things like on the back end and silly things like Java or C# and aren't using Node or whatever. These endless types of things go on, and they get worse when there's fewer and fewer jobs out there. The more people get argumentative, and the reason being is that they can feel threatened, sometimes legitimately so, about what their future is. And it's very hard to stay flexible and open-minded when you are being in an environment that's increasingly pushing you to, see your fellow programmers as a competition for resources versus colleagues in your journey to do better as a programmer and to help your company out. So again, to summarize, this market demand for code really leads to a much more surface level understanding. When I first started, it would be unheard of for anybody to think that you could learn to program in any serious type of way without 4 or 5 years of education, plus quite a bit of training after that. That's the other thing that's gotten lost is that certainly when I started, there was no expectation that I would know exactly what to do in a certain environment from day one. I was much more willing to be hired on my general skills and ability to learn. Nowadays, it's one of those things where if you do not seem to have this exact set of skills right out of the box, it is almost impossible to find a job. But that surface level comes at the cost of deeper understanding, especially in fields that now actually are more important than ever, that lead many developers to be stuck. If you're looking at what I am doing on this channel and why I talk about the Racket programming language, it may just seem that I'm having fun doing some coding again, and that's certainly true. But I firmly believe that the Racket programming language and the curriculum around it, or older versions of the curriculum around Scheme, are the best way to learn how to become not just a coder in a language, but to be able to program in whatever languages you want to, and to understand any language and its semantics and be able to much more rapidly adopt it and use it effectively than most people can. And I sincerely believe that if you put in that effort to learn this kind of stuff and to make the leap of faith that learning a programming language that you may never ever use again actually can lead to deep insights into what every programming language is and how it works, will pay off. And that while you may never get the amount of classes that I had to do in certain subjects, that certainly there are ways to explore those things after you've graduated, or if you've never really gone to school but are just trying to do your best as a programmer and want to learn more. So again, thanks for listening to this. If you made it this far, please leave a comment or a like and subscribe. I would love to hear some other opinions from people that may have a different look on this, especially if you think that the older types of more fundamental or theoretical parts of computer science really were emphasized from the very beginning. I think there's some interesting arguments around that as well. Anyway, hope to see you in the next video, and have a good one.